session we will design single slider crank mechanism and simulate the mechanism to study all its 4 inversions. So let us start. Go to the part design. Name the part as link number 1. Select the sketch plane. Go to the profile tool. Create the profile of the link. And let us make center of these two arcs symmetrical about the vertical axis using symmetry constraint. I will dimension this radius as 5 millimeters and center to center distance as 150 millimeters. Create one circle having a diameter of 5 millimeters. Make it concentric with one of the circular arcs using concentricity constraint. Create one more copy of this circle using symmetry tool. Add the material using pad tool on both sides of the sketch plane using mirror extend command by an amount of 2.5 millimeters. Go to the properties and change the color of this part. We will save this file in the folder named slider crank mechanism by the name of link 1. Now we will design link number 2, which will act as the crank in first inversion. Select the sketch plane. Again using profile tool, create the profile of this link. Make these two circular arcs symmetrical about the vertical axis using symmetry constraint. Let us change the value of this radius to 5 millimeters and center to center distance as 30 millimeters. Create one circle having diameter of 5 mm. Make this circle concentric with one of the circular arcs using concentricity constraint. Create one more copy of this circle using mirror tool from operation toolbar. Exit the sketcher. Add the material using pad tool on both sides of the sketch plane using mirror extend command by an amount of 2.5 millimeters. Go to the properties and change the color of this link to green. This is going to act as the crank in first inversion. We will save this file in the same folder in which we have saved link number 1. Now we will design link number 3, which will act as the connecting rod in first inversion. So making use of profile tool, create the geometry, make these two circular arcs concentric about the vertical axis, symmetrical about the vertical axis. Dimension the radius as 5 millimeters and center to center distance of these two circular arcs as 80 millimeters. Create one circle having diameter of 5 millimeters. Make it concentric with one of these circular arcs. Create one more copy using mirror tool. Exit the workbench. Add the material using pad tool on both sides of the sketch plane by an amount of 2.5 millimeters. Go to the properties. We will change the color of this connecting rod and save this file in the same folder in which we have saved link number 1 and 2. Now let us design link number 4, which will act as the slider in first inversion. For that purpose, draw the circle at the center of coordinate system. Specify the value of diameter is 14 millimeters. Add the material on both sides of sketch plane by amount of 15 millimeters, so that total extrusion length is 30. Use the shell tool, select this face and the opposite face, and thickness on the inner side as 2 millimeters. Enter the sketcher, select this surface as the sketch plane. We will produce one rectangular slot symmetrical about the vertical axis. So let us make these two vertical lines symmetrical about this vertical axis using symmetry constraint, as well as these two horizontal lines symmetrical about this horizontal axis. Dimension this vertical length or height of this slot as 10 and this width as 5 millimeters. Exit the sketcher. Use the pocket tool to remove the material throughout the extrusion length. Next, we'll create one datum plane by selecting the vertical plane at a distance of 20 millimeters. Select that plane as the sketch plane, enter the sketcher, draw one circle at the center of coordinate system. Specify the value of its diameter as 5 millimeters. Add the material using pad tool in opposite direction up to the next surface. Let us save this file in the same folder by the name of link number 4. Now we will assemble all these 4 links. For that, we choose the assembly module. Let us change the name of this assembly as slider crank mechanism. Select the name of assembly and select existing component tool from product structure toolbar. Browse to the folder in which we have saved all our 4 links. Now, first of all, we will insert link number 1. Okay. Apply the constraint of fix and check the degree of freedom for this. So there is no degree of freedom for link number 1, it is fixed in the contents of this assembly. Now repeat the procedure, click the name of assembly, choose existing component tool. Now we will insert link number 2. Use manipulation toolbar to position the links in the required direction. So I will make axis of this hole to coincide with axis of this hole using coincident constraint. Then select the contact constraint and choose these 2 surfaces and update these applied constraints. Now use manipulation toolbar to position the link Now let us insert link number 3. Now we'll apply the constraint of coincidence. To this axis and this axis, and contact constraint to this and this plane. And let us update the constraints. Now we will insert link number 4. Okay. Contact constraint, this surface with this, and contact constraint with this surface with this. Update these two constraints. Okay. Next, select coincidence constraint and select these two axes and update. Fitting on. Now we will hide all the constraints and all the planes. Now this is our assembly of slider crank chain. Let us check whether all the applied constraints are correct. Yes, we are there. Now we will simulate this to study the inversions. For that, select digital mockup and go to DMU kinematics. Now first of all, we'll create the revolved joints. Using this tool. Mechanism 1, axis of this link number 2 and axis of link number 1. So this surface of link number 1 and this surface of link number 2. Next, revolve joint between axis of this link and axis of this link, this surface and this surface. Now next revolve joint between axis of this component and axis of this pin. Offset between this plane and this plane. Okay. Now we will create a prismatic joint between this slider and this link number 1. It is asking for line number 1 and line number 2. So this will be our first line on link number 1 and this line on link number 2. This plane on link number 1 and this plane on link number 2. Now let us hide all the constraint symbols. So we have successfully created all the pairs between these 4 links. Let us check. Now we will create one command at revolute joint number 1, which is here. It will be angle driven now. We will change the range from 0 to 360 degrees. We will fix one of the links to get the inversion. First of all, we will fix link number 1, which is shown in blue color, to obtain the first inversion of the slider crank chain. Go to the simulation. Enter the command, insert it, put the simulation into the loop, change the velocity of moving links. So this is the first inversion in which link number 1 shown in blue color is fixed. Green link, which is link number 2, is acting as crank, and link number 4 is sliding with respect to link number 1, which is fixed. We will create the replay of this. Let us name it as first inversion. We call this first inversion of single slider crank chain as slider crank mechanism, which is used in air compressors and IC engine. So we can check the replay from model tree. Okay, we are done. Now let us change the fixed link to obtain the second inversion. Now for second inversion, we will fix link number 2. Let us simulate this. Enter the command, insert, put the motion into loop, change the velocity and play. In this case, link number 2 is fixed, which was crank in first inversion, and link adjacent to this fixed link will act as cranks. They will exhibit full rotation. This inversion is used in quick return mechanisms. Let us create the replay of this as second inversion. Now to obtain the third inversion, we will fix link number 3. Fix the connecting rod. Now let us simulate this. Enter the command, put the mechanism into loop, change the speed and check it. In this you can see Green link is acting as the crank. And this link number 4, which was slider in inversion 1, is oscillating about the fixed pivot lying on this fixed connecting rod. This inversion is used in oscillating cylinder engine mechanisms. Let us create the replay of this as by the name of third inversion. Now to obtain the fourth inversion, we will change the fixed link. Now we'll fix link number 4, that is the slider in the first inversion. Enter the command, insert it, put the mechanism into loop, change the velocity, and check. Now in this case, link number 4, which was acting as slider in inversion 1, is fixed, and link number 1 is sliding inside the fixed slider. Green color link is acting as crank, and this connecting rod is acting as the rocker. This inversion is used in hand pumps. So, fourth inversion remember that in all these inversions of single slider crank chain, irrespective of the type of link you fixed, relative motion between two adjacent links remains same. So this is first inversion. This is second one. This is third one, which is obtained by fixing connecting rod or link with two revolute pairs. And this is fourth inversion, which is obtained by fixing link number 4. Thank you.